Good day everyone. Our lesson for this video is about a sequence. When we say sequence, it refers to a set of numbers or objects arranged in a specific order. Each number or object in the sequence is called term. Also, we have number sequence. It is a set of numbers arranged in such a way that each successive number follows the preceding number according to a pattern or rule. A rule defines which way to reproduce the value of each term of a sequence. Without a definite rule, a sequence cannot be formed. Also, we have two general types of sequence. First, we have finite sequence. Finite sequence is a sequence that has a limited number of terms. The terms are denoted by a sub 1, a sub 2, a sub 3, and so on until a sub n, where n is a natural number. Also, n refers to the order of the terms. Again, n refers to the order of the term. Next one, we have finite sequence or infinite sequence rather. Infinite sequence is a sequence that has endless number of terms. It is also associated with the concept of infinity or forever. To indicate an infinite sequence, you may use ellipsis. Ellipsis is in the symbol of 3 dots. So let's proceed to sample problems. Okay, for number 1, we need to give the first 5 terms of the sequence whose nth term is given by each of the following formulas. For the first formula, we have a sub n is equal to 2n plus 5. So in finding the first 5 terms of the sequence, we just need to substitute each term to n until 5. So for example, we have a sub n that is equal to 2n plus 5. In finding the first term, we just need to substitute 1 here in our n. Remember, n represents the order of term you are going to find. So for the first term, we will just use a sub 1 that is equal to 2 times 1 plus 5. So we have 2 times 1, 2 plus 5. Therefore, your first term is equal to 7. Okay, for the second term, we have a sub 2 is equal to 2 times the value of your n here, that is 2. Take note, class, in every term that we're going to find, the value of n should be uniform. So we have here plus 5. Next, 2 times 2, we have 4 plus 5. And our second term is equal to 9. Next, for the third term, we have a sub 3 is equal to 2 times 3 plus 5. So we have 2 times 3 is 6 plus 5. Therefore, the third term is equal to 11. Next, for the fourth term, we have a sub 4 is equal to 2 times 4 plus 5. So 2 times 4 is equal to 8. Next, we will add 5. Therefore, it will give us 13. So the fourth term is equal to 13. For the last term or the fifth term, we have a sub 5 that is equal to 2 times 5 plus 5. So we have 10 plus 5 that is equal to, yes, that is 15. Therefore, we have 15 for a sub 5. So we will now list the first 5 terms of the sequence defined by a sub n that is equal to 2n plus 5. So we have 7 for the first term, 9 for the second term, 11 for the third term, 13 for the fourth term, and 15 for the fifth term. So this is now the first 5 terms of the sequence an that is equal to 2n plus 5. So can you determine the pattern of this sequence? Actually, we can say that this is the pattern, but in some other form, you can just state the pattern in a form of a sentence. For example, the given sequence is in this format. We have 7, 9, 11, 13, and 15. As you can notice, we are adding 2 in each of the previous term to find the next term. So we can say that the pattern of this sequence is by adding 2 to the previous term to get the next term. So we can say, instead of using this pattern or formula, we can say also, or we can also state it in the form of a sentence or a phrase. So we have, by adding 2 to the previous term to get the next term. What if we have this problem? How are you going to find the first 5 terms of the sequence? Okay, so we will solve this together. So we have a sub n that is equal to negative 1 raised to n times n. Take note, the other n here serves as the exponent, and the other one is a base. So we will start finding the first 5 terms in the first term. So we have a sub 1 that is equal to negative 1 raised to 1 times 1, or negative 1 rather. So we have negative 1 raised to 1 is still negative 1 times negative 1. So the answer in multiplication, take note, if we have like signs, the answer is always positive. However, if we have unlike signs, the answer will be negative. Very good. So we have here positive 1 for a sub 1 or the first term. For the second term, we have a sub 2 that is equal to negative 1 raised to 2 times negative 1. Next, we have negative 1 times negative 1 is equal to positive 1 times negative 1. Therefore, the answer here is negative 1. So a sub 2 is negative 1. Next, for a sub 3, we have negative 1 raised to 3 times negative 1. So always remember, if we have a base that is negative and an exponent that is odd, the answer is always negative. So we have negative 1 times negative 1 is positive 1 times negative 1. It will give us negative 1 times negative 1. So the answer here, a sub 3 is equal to positive 1. Very good. Okay, for a sub 4, we have negative 1 raised to 4 times negative 1. So in this case, we have negative base and an even exponent. So if this is the case, it will give us a positive answer. So we have positive 1 here times negative 1. The answer for a sub 4 is negative 1. Very good. So for the last term, or a sub 5, we have negative 1 raised to 5 times negative 1. As what I have told you a while ago, if we have negative base and odd exponent, the answer is negative. So we have negative 1 times another negative 1, so we have positive 1. So we have now the first 5 terms of our sequence defined by the formula or the pattern a sub n, that is equal to negative 1 raised to n times n. So we will now list all the terms. So we have 1, negative 1, 1, negative 1, and positive 1. So these are, or this is now the list of the first 5 terms of the sequence defined by this pattern or formula. So in sentence, how can you define the pattern of this sequence? For example, hindi ito given yung sa taas, and the only given is this sequence. How can you define this pattern without using this pattern? Okay, for the format of a phrase or sentence, we can say by multiplying negative 1 in the previous term, to what? To obtain or to get the next term. Simple as that.